In the following video, we will be doing a walkthrough the Kubernetes op. The Kubernetes op is one of the CTO.ai official ops, and it was built and designed to facilitate interaction with existing Kubernetes clusters. Before we jump into the demo, let's just quickly have a look at some of the prerequisites and the setup instructions that are captured in the README of this op. As requirements, obviously, we need to have the ability to connect to a Kubernetes cluster that we will save in our configuration so that we can interact with it. Currently, the op supports both Amazon Web Services EKS clusters as well as Google Kubernetes Engine clusters. So one main requirement would be for the person running this op to have the configuration, the kube config of that cluster, because it will be required in the configuration of the op. In addition to that, we also require the users to have certain service accounts created on AWS and GCP with very clear permissions that we've actually captured in the documentation in here. And these service accounts need to have credentials generated for them so that the user can configure them as secrets in the ops team. There are detailed instructions on how to do that in the README. The other aspects that are captured in the README just walk through the main features in the op that we'll walk through in a few minutes, as well as mention some details as to how one can contribute to this op. So let's jump and start this op. In order to start it, we will run ops run k8s. And what happens right now is we are actually pulling the code behind this op and starting a pod in our infrastructure, in the CTO.ai infrastructure that runs the Docker image of this op. While this is getting started, because it's a very powerful op, it's worth mentioning that this op complements some of the other ops that the team has been working on that facilitate the creation and deletion of EKS and GKE clusters. Now that the op has successfully started, the first step that we have to go through is to select the cloud provider that we would like to work with. In today's demo, we are going to use the GCP. Notice how we are automatically retrieving the credentials that allow us to connect to GCP and have the right permissions to interact with the clusters. These have been previously set following instructions in the README in the team that we're running this in. The main actions that a user can do with this op can be viewed in this list. The first step is the configuration of the cluster, which we will skip because we have done this ahead of time. And we saved the kube config of this cluster as a secret in our team. So let's jump in and check out the list resources option. What this one does is it allows the user to get an overview of what's available in their cluster. As of now, we support pods and deployments, so they can see what pods and deployments exist in either a specific namespace or across all namespaces. One of the requirements of the op is for the user to also know what region the cluster is deployed in. In our case, we mentioned we are going to do this with a cluster in GKE. We have this one open in here, so we can confirm some of the things that we're doing are being applied correctly in the cluster. Notice it is in Australia Southeast. And we have previously saved the configuration of this cluster, and we named it demo. So the op can automatically retrieve from the secrets the configuration of this specific cluster, so we don't have to do this every time. So as we're trying to list resources now, we have the option to select a specific namespace, or we could be getting all of the resources across all of the namespaces. Let's go ahead and see if we have any deployments in our monitoring namespace. Excellent. So we can see that there are actually several deployments in our now monitoring namespace. We seem to have Grafana and Prometheus installed in our cluster. We're going to show you in a few minutes how that was also achieved using this op. So now that we've seen the resources, we can go ahead and explore another option in the op. So we can go back to the main menu and let's try to deploy an application. This is a very powerful feature that makes it really easy for a user that has a Docker image and knows the configuration of their application to very easily create a deployment with that application in the cluster and expose it to the internet. So the first step is to select a namespace for our application. Let's just go with the default namespace. We can see we already have an application called Nginx in the cluster, and we're going to select a name for our application. So let's just go with hello. So now we need to pass the Docker image of our deployment. So I just have a quick hello world example that we will be using that's currently deployed in the Google Container Registry. We know that this application is running on port 8080. So we're configuring the port and the target port of our deployment, and we have to select the number of replicas that we would like to start with. Let's just start with 1. And yes, we would like to expose the application outside the cluster. Let's assume we would have access to this subdomain. And the nice part about, we can start with 1 replica, but we also make it really easy for the users to use this op to configure horizontal pod autoscaling so that the application can respond really well to traffic surges. So we can configure the application to always have a minimum of 1 replicas and can go as high as 5 replicas. And the scaling will be done based on the CPU utilization percentage, let's say when that hits 65%. Excellent. So now that we've configured all of these aspects, we can do a quick check to make sure that everything looks okay, and we can confirm that we are ready to begin deployment. So going back in the Google interface in here, we see already that we have a hello deployment, as well as an ingress resource and a service ingress. So we can go back in here and notice we get the same information that we just confirmed in the UI. We had a deployment, a service, an ingress resource, as well as a horizontal pod autoscaler configuration, which we should be able to easily see by clicking on the deployment details. Notice in here that we have the minimum and max replicas in here. So we've just seen an example of how easy it is to deploy an application using this op. The next thing that we're going to showcase is installing and uninstalling Kubernetes tools. By Kubernetes tools, we practically mean popular applications that are often very useful to be installed to a cluster for monitoring or for being able to get visibility into what's happening in the cluster. We support the metric server, Kubernetes dashboard, Nginx ingress controller, and Prometheus and Grafana. In this case, GCP already handles automatically the metric server in the Kubernetes dashboard, so the only options we offer are the rest of the other 3 ones. It seems we already have Prometheus and Grafana installed. We've already seen this earlier when we listed the deployments. So we're going to go ahead and install the Nginx ingress controller. Confirming that we are good to go. This usually takes a few minutes as we're leveraging Helm behind the scenes to download the chart and configure it accordingly and then install it in the cluster. The op will let us know in Slack as soon as this is done. And there you go, we have installed successfully Nginx ingress controller. So in a similar fashion, we can go ahead and try the uninstall option, and it will let us know what's already installed and let us uninstall it. We're just going to skip that because it's very similar. The last option we currently support with the op is the ability to create resources from YAML. This is a very powerful option. Obviously, any kind of Kubernetes resource can be created by just pasting the YAML. This is where we leverage our secret management feature. And in particular, we leverage the browser manual input option so that the user can paste the YAML in here without having to expose all of those details in Slack. We have an example of a secret. So let's say we want to create a secret in our cluster where we store the username and let's say the password as well. Do not use these because they're not good. So we're using string data, but eventually they will be encoded, so they're not easily accessible to people looking in the cluster. Excellent. So now we've pasted the YAML in here. We've called it my secret. Let's submit. And you'll notice that we already get a confirmation that the secret was created. Let's quickly go into the Kubernetes UI and make sure that this shows up in here. And we can see my secret configured in here with the 2 fields that we've just included in our configuration. This concludes this demo. Thank you very much for your attention.